One of the prominent themes in so many DevOps Enterprise Summits has been site reliability engineering, which I've always been dazzled by. There are so many interesting things about these principles and practices that Google pioneered back in 2003. I think it's one of the most incredible examples of how one can create a self-balancing system that helps product teams get features to market quickly, but in a way that doesn't jeopardize the reliability and correctness of the services they create. For over a decade, I've wanted to better understand why Google chose a functional orientation for the site reliability engineers. To this day, thousands of Google SREs are still in one organization reporting to Ben Traynor-Sloas, VP of 24/7 Engineering, which includes SRE, very purposefully outside of the product organizations. Undoubtedly, this creates certain benefits, as well as certain complications. I can't think of two better people to explain the implications of this to technology leaders. Dr. Jennifer Petoff is Global Director of SRE Education and is one of the most widely cited authors in this space. She will be co-presenting with Dr. Christof Leng, SRE Engagement's Engineering Lead, who has managed and worked on various parts of Google services, including cloud, ads, and internal developer tooling. Here is Dr. Petoff and Dr. Leng.
Welcome to our talk about the collaboration between Google's site reliability engineers and developers. I'm Christof Leng, and I lead 3 teams in a horizontal function called SRE Engagements based in Google's Munich office. These teams work on improvements for all of Google SRE. One of my responsibilities is to maintain the SRE Engagement Model, the collection of policies that define how collaboration between SRE and the developer partner works, which is what we're going to talk about today. I've been working at Google since 2014 on various products, and before Google, I was a distributed systems researcher. Over to Jennifer.
Great. Thanks so much, Christof. Hi, everyone. I'm Jennifer Petoff, but my friends actually call me Dr. J. I'm Google's Director of SRE Education, and I'm based in Dublin, Ireland. I've actually been at Google for 14 years. I like to think that time flies when you're having fun. You may be wondering, why Dr. J? Well, I have a PhD in chemistry and started my career in the lab working on things that could start on fire or explode if you expose them to air. I currently lead the global SRE education team, or SRE EDU as we affectionately call it. And I'm also one of the co-authors of the original SRE book that we published back in 2016. Of course, when we aren't living in a pandemic, I love to travel, and I'm a part-time travel blogger at Sidewalk Safari. All right, so now that we've been properly introduced, let's start with some context on complexity. So if you think about it, at 2 billion lines of code, or more than 2 billion lines of code, it's not an exaggeration to say that Google's production environment might be one of the most complex integrated systems ever created. It's also highly interconnected, which is a key enabler, but also creates many challenges at this scale. The systems that you run may be smaller than that, but it probably depends a lot on third-party code, external dependencies, and maybe even a cloud platform or two, of course. While this is a case study about Google and shouldn't be applied verbatim to your organization, the challenges of scaling with complexity are universal. So given the scale and complexity, that raises the question, how do you run a planet scale system? How do you keep it stable? How do you add new functionality to it? So let's look at balance. Reliability and velocity are oftentimes at odds with each other in the traditional software development model. Developers push for velocity to quickly launch new features, and ops pushes for reliability and to slow things down. This is inherent to the way the incentive structure is set up, but the reality is that you need both aspects. You need reliability, and you need to also move fast. So how do you find the right balance and actually resolve this potential conflict? So one way to do it is to sidestep the problem. And what we've done at Google is actually create a discipline that balances these competing concerns of reliability and feature velocity. Ben Traynor-Sloas, the founder of SRE at Google, actually describes SRE as what happens when you ask a software engineer to design and run an operations function. So SREs come from many different backgrounds, but what they have in common is a mix of software engineering and systems engineering backgrounds. We know how to build and how to run systems, and we deeply care about both aspects. So SREs focus on reliability to meet the availability targets our users need while maximizing long-term feature velocity. SREs also focus on maintainability, so ensuring that we aren't feeding the machines at human toil, where we define toil as work that's manual, repetitive, automatable, tactical, so interrupt-driven and reactive, and gives no enduring value. Toil also grows linearly with service growth, which can be problematic. Of course, efficiency is also important, so using engineering time and machine resources as efficiently as possible. Now, let me turn it over to Christof to tell you a little bit more about the scope of what we work on.
Thank you, Jennifer. So SRE at Google, unlike many similar functions at other companies, is one central organization that takes care of many different areas across Google engineering, from user-facing products that everyone knows, like search and YouTube, to internal infrastructure like network or developer tools that our users never interact with directly. It has been tested, applied, and adapted to many different contexts across Google over more than 20 years, almost 20 years. The overall organization is more than 3,000 SREs nowadays, which is big. However, Google SRE is grouped in what we call product areas, a group of related services and products, and each has overall, let's say, 50 to 300 SREs. And each of these product areas partners with a developer organization that develops these products. But the developer organization is typically much, much larger. And this